Okay, hello. So I want to show you a different approach on how to make agents actually be performant in repositories. I feel like a lot of the AI influencers on YouTube, they are working in a bubble. They are working alone on their own projects. They have all the freedom in the world to just try out different things and be very, very opinionated. And they don't have to discuss anything with anyone. But I work in a team. I work on multiple repositories, and I felt like this threshold of how are we going to apply AI to these projects, and do we even believe in an AI being able to actually generate code in this project? So, and the way we kind of evaluate this now is that we just shove an agent into an existing project, we prompt it on one end, and then we evaluate the generated code on the other end. And then we feel like, no, this isn't good. And then we're like, no, this is not gonna work. Because we don't understand why it generated that specific code, right? The stuff in the middle, the way it retrieved its context and evaluated that was the right solution, we don't understand what's happening there. It's just way too much information. So we need a different way of approaching this that's more fundamental. It's not opinionated by any specific harness or model or skills implementation or MCP or whatever it might be. Something that the team can start very, very small on, like the minimal commitment, and then iterate from there. And the way I'm going to show you this now is just a repository. This is not a team-based repository, but I wanted to create something simple to kind of give you the idea so that you can explore this on your own. What I've done here is that I have a very basic project running on Vite and React and TypeScript and things like that. And then I have the starting point. And the starting point is instructions. So when you shove an agent into a repository, it has kind of a very generic set of instructions on how to approach any code base, right? But you want to narrow that down to specifically this code base. And the way you would need to do that completely generically is that you need a Claude MD file if you're going to use Claude. But in that Claude MD file, you just point to the agent MD file because everyone else is using agent MD. But if you do @agent MD, that agent MD file is also going to be written to the session when the session starts. It's not like Claude goes in and does a tool call to read the agent MD file. This is injected into every single session. And now the question is, okay, I have this agent MD file. What am I going to put in it? And this is something to explore and iterate on, but I can show you what I've found to be efficient. So let's see here if we can. Yeah, let's do this. So the most important thing is to have a project structure. Like you've organized this project into different folders, and these different folders, they have different meaning. And you might have different kinds of code that should be implemented in the different folders. But not only that, certain folders are related to testing, for example, or maybe you have some scripts that can be run, or what we're going to explore is specific folders for agent instructions. So what I've done here is that I've put in a plans folder, and this is tied to a workflow I've defined that's called plan. And we're going to look at that later. And then I have a scripts folder, which is related to writing different scripts that the agent can use to retrieve additional context. So as I said, we're not using MCP servers or CLI tools directly. And the reason is that, first of all, they have different configuration for different agent harnesses, but also it's about authentication or authorization to context. Like MCP servers and CLI tools just has like a single authorization. They are generic, right? And you don't want to expose your agent to everything. So what you rather do is that you create scripts, which are like purpose specific to the project and what the agent should have access to. So you can imagine, okay, we're going to have a script that allows the agent to create a PR, but that doesn't mean it should be able to create an issue, for example. So you create a script that's specifically for creating a PR. Or maybe you don't want it to create a PR at all, but you want it to be able to read issues, for example. So you create a script that allows it to read issues, but maybe you don't want it to read everything from an issue, because these are verbose data structures. So in that script, you can minimize the actual data that goes back into the context of the agent, which makes it more efficient. So, and this is incredibly cheap to create because you can use the AI to create these scripts. So this is all about like creating instructions for the agent. So I have a script here, which is list recent plans. And that is with the idea in mind that you could have hundreds and hundreds of plans that's been committed to the repository. So you want an efficient way for the agent to be able to just list the recent ones. With workflows, they are basically like skills, only they're not like put into the harness configuration. It's just part of the general instructions where I have a research workflow, a plan workflow, an implement workflow, and a UX workflow. We can take a look at them. And then we explain the actual code of the project, where to put the assets. In the components folder, we have domain components that can only read state, call state methods, and render UI. And these are React components, which is functional. I have a context folder with React contexts. We have a services folder, which is the interface between the actual application and its environment. So anything to like do HTTP, local storage, or using third-party libraries, all of that is defined as a specific interface towards the app. And this is just good programming because it makes it more testable. The app is more flexible in the sense that it can move into different environments without changing the internals of the app and so on. And then we have a state folder, which is the domain truth. This is where the data is loaded. We compute values. We have methods for changing the state. And I'm using a project I'm working on now, which allows me to define this as classes. And this is object-oriented mutable state. And then we have UI components. And the reason I'm going through this is I'm explaining that like these different folders represent very different ways of programming, right? And you want to be very specific about what kind of approach should you have when creating files or changing files in this folder. While UI components are generic reusable UI primitives, they don't know anything about the app domain, and they can use internal state. So I have an application where the components uses a specific state layer, while UI components are allowed to use their internal state. And then it also explains that we have our style guide with color tokens and so on in our design MD. And then it emphasizes the architecture of the app. As I said, we have services as an outer layer, then we have our state, we have our components, then we have our UI components. Where services and UI components are completely generic, they don't know about the domain, but state and components do. And then I've listed scripts. So in this case, we only have list recent plans. But we would have more scripts here. As I said, these are specific scripts to reach out into the external world, it being Bash or, it being the codebase to more efficiently retrieve context, it being external, it being some specific functionality from a CLI. It doesn't matter what it is. And then the interesting part is, how does the agent actually do its work? So I want it to be, I want to trigger it to go into a very specific set of instructions based on what I'm asking it. And I could ask it many different things, right? It could be, I'm gonna explore something new, like doing research, or I want to, for example, always create a plan before doing implementation. And I want that plan to have a very specific format. Like you get a plan mode from Claude, for example, but that plan mode is a very generic instruction and a very generic output that might not be what you want. So as an example here, we can jump into the plan. So when it decides to go into plan mode, which I've also written when it should do, is that it actually goes and reads the plan file. And this is why models are so good now, and why we can do this is, or the reason we can do this is because the models are so good now at actually following these instructions. So I've told it to, before it writes any code, it needs to produce a plan, and it should write that plan into the plans folder. And this is the format of the plan. This is the file name, and then this is the format. It should have a title, it should have a summary, it should have considerations, because I want it to reflect on multiple options. And then I want it to write down the tasks it intends to do. And then I want it to also give a report at the end. So when it moves into implementation, which I've described here, it works with the plan, it updates the plan, and then writes a report at the end of the implementation. And then I was like trying this, and I tried to plan first, and that felt good. And then, okay, let's create an implement workflow. I tried that was good. And then I noticed that, oh, actually, when I want to implement something that affects the user experience, I really wanted to help me reason about that user experience to make sure that I don't, that we consider all the possible states that the user can get into, and how should each interaction actually work, and what's the expected outcome, and all of this. And here you could even tell it to go and create like an HTML file for you, like as a proof of concept. So you can like interact with something and play around with it before you go to implementation. Like this is stuff we do as engineers. But it's just not like an actual set of instructions that we follow. Those instructions are just our experience in our head, right? And that's what I think about here as senior engineers working with agents, is that we need to bring those instructions, that intuition that we built up through our experience, and we need to write it down into a set of instructions that the agent can follow to operate efficiently in the repository. Maybe we can look at, so I have some plans here. So for example, I added some testing because I wanted to explore like, okay, how we're going to make the agent validate that it actually implements things correctly. And the way this is set up is using vtest, and it's able to mount any component, wrap the state of the application around it. It can mock all the services. It can change the state of the application before it renders the component. Everything in isolation, so it runs really fast. And then we can look at, okay, these are the considerations I had to make, and these were the tasks. And I think this was before we added the report. While I think I have another, yeah. So here I added the report. So here you can see what it did, and if it met some issues, it had to change its, it discovered something through the tasks, it would actually report that here. Cool. And then for design, just like color palette, theme tokens, just a general style guideline. Cool. But this is actually it. It's just to summarize very practically, create a Claude MD file, point to an agent MD file, describe your project structure, describe how you want the agent to meet you when you ask it something, define specific workflows, how those workflows interact with each other, and then use scripts to provide additional context to the agent. Don't use MCP servers, don't even use CLIs directly. Create scripts that gives it exactly the context that it needs to have. And then what happens is that when you run the agent and it generates output and you review that output, you don't just review, is this generally good code? You will start reviewing it against your instructions, right? So you see immediately like what your expectations are because you've written these instructions, which embeds your expectations. And when it generates some code and you see that there's something wrong here, you can go back to your instructions and see where did we go wrong? Why didn't we? You can even freaking ask the agent, why didn't you follow this instruction? Or what would you suggest me adding as additional instructions so you don't do this mistake in the future? Or write a script for me to go and grab some data from our logs on Sentry, for example, so you can better understand whatever it might be. So that kind of iterative enhancement of the agent, which is completely generic in this setup, I think is a much more like fruitful and lower threshold approach to actually make agents much more efficient in any code base that you work on personally or with a team.